there are other sentiment tasks than just simple positive or negative polarity. One important one has to do with finding the sentiment of an individual sentence, which we're going to want to do for finding aspects or attributes that we talked about earlier. So that's finding the target of the sentiment, what it is that we're talking about the sentiment about. So here's a sentence: the food was great, but the service was awful. This whole sentence doesn't really have a sentiment. It has a positive sentiment about food and a negative sentiment about service. So we'd like to be able to deal with this kind of micro sentiment where we have a sentiment about one attribute and a different sentiment about a different attribute or aspect. So how are we going to find the aspect or attribute, or sometimes it's called target, of a sentiment? And I'll show you an example that a way of doing things that was developed both by Hu and Liu and by Blair Goldenson et al. And the idea is we first look through all the reviews and we find every highly frequent phrase. So let's say that the word fish tacos occurs a lot in this particular restaurant reviews of this restaurant. And then we mark down, we have filters that say we prefer highly frequent phrases if they occur right after a sentiment word. So maybe we very often see the phrase great followed by fish tacos, or terrible followed by fish tacos. That suggests that fish tacos is an aspect, a likely aspect of let's say a taqueria. So if we see great food a lot, if we see food occurring very often in a review, and we see the word great and terrible and awful before it a lot, we know it's probably an aspect that people are applying sentiment for. And this can be used automatically to find sentiment for lots of things. So Blair Goldenson et al. Used it, for example, for casino reviews of casinos to find words like casino, buffet, pool, resort, and beds are the kind of things people comment about in reviews on casinos. For a barber, you might talk about the experience or how good a job it was, or facts about the haircut. For a department store, you might talk about sales or different departments or the selection of the store, things like that. So we can automatically find the aspect. In other cases, though, the word that describes the aspect may not be in the sentence. And so for some sentiment topics like restaurants or hotels, it's pretty well understood what the aspects are that people care about for restaurants. For restaurants, they tend to care about food, decor, service, value. And so for cases where we know in advance what the frequent aspects are, here we can take a small corpus of restaurant reviews and we can hand label it. We'll just mark every sentence. Does this sentence talk about the food? Does it talk about the decor? Or is it none of the above? And then we can just build a classifier which, given the sentence, assigns an aspect to the sentence. Is this sentence about food? Is this sentence about decor? Sentence about service, and so on. And it could be a sentence, or we could assign that with phrases, or maybe with clauses, with pieces of sentences, whichever we'd like to do. So two ways of finding aspect of a sentiment. We can automatically find frequent phrases, so we can find phrases. And then we can build up a set of phrases that occur frequently and decide those are good phrases that we'd like to know about for this particular product. Or we can decide the aspects in advance. Aspects are come in advance, like we know what they are for restaurants. And then our job is just to build a little classifier to find them in the review so we can decide if what person said about the food was positive or negative. So putting this all together, this is the Blair Goldenson algorithm from Google. We have a set of reviews. We're going to extract a bunch of sentences or phrases. So here's our extracted sentences or phrases. And now for each one of them, we're going to run our sentiment classifier. Is this phrase positive, negative, or maybe it's neutral? Okay. And then for the ones that have sentiment in them, the ones that are positive or negative, so now we have sentiments and phrases with sentiment, plus, minus, minus, plus, plus, minus, and so on. We're going to extract the aspects of these. So is this about food? Is it about decor? What's the sentence about? And so now we have plus food, and now we have minus decor, minus service, and so on. For each sentence or phrase, we have both a sentiment and an aspect. And now we aggregate these together and produce a final summary. And here's an example of what you might get as the final summary. So maybe for a hotel, for rooms, we might get that this sentence, the room was clean and everything worked fine, positive sentiment, another positive sentiment. Here's an example of negative sentiment. So we first figure out that worst is a negative sentiment, and then we might extract from somewhere in here that there's some mention of rooms. And similarly for service, we might see service gives new meaning to slow, and that's negative. We made some simplifications in the baseline method we gave for sentiment classification. We assumed that the classes, positive and negative, occurred with equal frequency. And that's, of course, not usually true in the real world. And it turns out that when the classes are not balanced, we can't use accuracies as an evaluation. And the F-score can deal well when evaluating classes where there's many more positive than negative, or maybe there's many more negative than positive reviews. It turns out that if there's a severe imbalance in class frequencies, that can actually degrade the classifier performance. And there are two standard things we do to deal with that. One is we just resample before we train. So for example, if one class has 1 million reviews and one class has 10,000 reviews, then we might just downsample and take only 10 to the fourth of these reviews to match with these reviews. Instead of resampling, we can use cost-sensitive learning. Cost-sensitive learning, we actually change the classifier, and we tell the classifier, even though this one, you've seen a lot more of this frequent thing, penalize it for misclassifying the really rare thing. And so that'll force it to focus a little more on the rare things than on the very frequent things. So two things you can do to deal with the imbalanced frequency problem that often occurs in real classes. We also, in our baseline algorithm, made the simplifying assumption that sentiment was a binary problem, positive or negative. So how do we deal with 5 stars or 7 stars or 10 stars? So there's two ways we can do this. We can map onto a binary class. We can say things that are more than 3.5 stars are positive or less than 3.5 are negative, or we can take the average of all the data. We can z-score. We can do various ways of drawing a boundary between positive things and negative things. Or we can actually attack the 1 to 7 classification task directly by using linear or ordinal regression or specialized models like metric labeling that's used by Pang and Lee. So again, we can either downsample and just do binary classification, or we can use a more advanced method of classification that lets us predict an ordinal value or a real valued number. So in summary, sentiment, generally modeled as a classification task. Polarity, often with binary, less often with some kind of ordinal or linear valued label. And negation, a very important feature to use. For lots of tasks, using all the words in naive Bayes seems to work well. For other tasks, using subsets of words may help, and we can either use hand-built polarity lexicons, or for tasks for which the polarity lexicons seem inappropriate, we can induce lexicons using semi-supervised learning from some hand-built seeds. Now remember that sentiment is really just one of many kinds of affective state. It's a kind of attitude classification, but there's lots of other kinds of affective state classification that come up in their computational problems that are very similar to sentiment analysis. So to look at some of them, for emotions, we might want to detect annoyed callers to some dialogue system. So it's detecting the emotion of annoyance, or detect confused or frustrated students in an online tutorial versus confident students. For longer term moods, we might want to find traumatized or depressed people, like writers of some blog or text. In conversations, we might want to detect if someone's friendly or unfriendly. In very long-term personality traits, we might want to detect extroverts or introverts for building dialogue systems that can communicate better with extroverts or introverts. And there's lots of research actually on all of these tasks. We'll just show you one of them, which is a task we've worked on here at Stanford, which is detection of friendliness. So friendly speakers use, it turns out, use collaborative conversational style. So we built classifiers that look at features like how often someone laughs, or how often they use negative emotional words, or how frequently they use phrases like "that's too bad" that indicates sympathy, or agreement, "I think so too." So the more friendly someone is, the more likely they are to use sympathetic words or agreement, or the less likely they are to use a hedge like kind of or sort of. And we've shown that these classifiers help in, we've looked at the task of detecting how friendly someone is or how flirtatious someone is in speed dates. And we found that these kind of features help in detecting friendliness. So simple lexical features like words and phrases, and where we have speech, speech features like prosody or pitch, all of these can help in detecting sentiment, simple polarity, and much more rich effective meaning of all sorts of kinds.